I have no comments.
Really?
Seriously, I don't know what to say.
Is it an emotional thing for you?
Gives me some anxiety for sure.
Yeah. Well, it gives the world anxiety right now. So I can only imagine you being that much more closely tied to it.
Is your family there?
My mom is. Yeah.
Sorry, man. Okay, so how many people in here have taken the Chapter 2 test? I want to see every hand. I want to see, raise them high. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so about half of you. When does it close? When does it end? Today. This is it. This is the last day to take that test for the first time, right?
Well, yeah.
And then you can retake it through Saturday at midnight, but you've got to take it for that first time by tonight, or you'll fail the class. You got to get that deadline met. Okay. There will be more need for retakes on this test than there have been on the first two. More desire for retakes as well. Some of you will, for the first time, be like, "Hey, I want to retake that test." Make sure to read the syllabus, okay, about test retakes, so you understand how to prepare and what all you need to do. Test retakes are a great gift, so make sure you take good care of that and give it the respect that it deserves, because it's a great opportunity for you to bolster your score. We are not going to talk anything about Chapter 2 today. We talked enough last week. We went on a review on Wednesday and Friday both. And so today we're going to jump into Chapter 3. My ideal situation, I think, for all of us is to get closure on something before we begin something new. But for half of you, that is not possible because you haven't taken the test yet, but that's all right. Today's assignment will be easy, and not easy from a teacher's perspective, definitely easy from a student perspective. How many people in here have ever looked at a paper map? A paper map, okay? I would imagine that by the time your children are going to school, that number will diminish to only 1 or 2 hands. The digitization of maps has become prevalent in the last 20 plus years. MapQuest, Google Maps, all of your navigation systems in your vehicles. We don't really look up paper maps anymore. I want to hear your experiences though. What paper maps have you looked at in your life? When did you have to look at a paper map? Yeah.
Like road traveling.
Yeah.
And all that. Yeah.
Like family tells an experience, right?
Well, I think we were just traveling around Utah, or like going to Utah from California when we were really young, and all that. And so my mom brought out the
Yeah,
when
they unfold and refold them, and you can never get them to fold back properly. And
yeah. And there's just like, I remember always like seeing like just like tons of dots.
Right.
On there, because they would like circle like, oh, this is where we need to go, and oh, we have to take the I-90 or I-50.
Yeah, that's cool. That's cool. Who else? Map experience. Yeah.
In my freshman year in high school, I had a geography class.
Yeah.
And we had like 4 different maps spread out, and for the test, he gave us like a mini copy of those maps that were blank. We had to like do the geographic, but then like the urban version.
Gotcha.
Version.
That's cool. That's cool. Nice. What else? Yeah.
For hunting, we use topographical maps.
Oh, cool.
We have to map where we're going, what the terrain's like, all that stuff.
Yeah. I bet if there's not already an app, you could make a hunting map digitized where you could put stuff in, and then while you're hunting, it would take you to those coordinates or something like that. People would be all over that action, man. Make some money off of that.
There's actually some apps that are like that.
Yeah,
they
that makes
do
sense.
That with fishing. Like,
That's cool. What else? Yeah.
When I was 8, my family and I took a trip from here in Idaho all the way to New York.
Okay.
And the trip took about a month, but we did use maps, and by the end of the trip, our glove box was just crammed full of maps from every state and stuff.
That's cool. Good memories, man. Good memories. Yeah, Adrian.
On the Philippines, when I was in the Philippines, we would hike a lot.
Yeah.
We used like
Kind of like snakes, just visiting
paper maps, and some of those maps are like does not have any other copies. We only have it.
Oh, wow.
Yeah.
Wow. So there's one in existence.
Yeah.
That's cool. That's really cool.
There's like a falls that only like a few people are doing.
Wow.
Yeah.
That's awesome. Cool stories. I know on a mission, I use maps more than any other time in my life. You get into your area, and there was always maps in the, area binder, and, and you'd have to look up streets and stuff. And I remember we had an atlas. Did anybody in the family have an atlas? You know, that made the unfolding the map less, problematic because you just flip the page to the different states. I was intrigued by, like, California took, was a whole centerfold, it was like, it took 2 pages, that kind of thing. So, yeah. All right. So, mapping. We're going to be talking about mapping in the math world. Let's first talk about just making a map here. When you looked at those maps back in the day, by the way, there's maps in the back of the Bible. It used to be called, does anybody know? Anybody know what it used to be called?
No, I don't remember, but I know what you're talking about.
Yeah, it's the map section, but it used to be called the Gazetteer. Did anybody know that? Anybody ever see that before? The Gazetteer. Gazetteer. It's a really weird word, man.
So weird.
I know. Anyways, I'm sure it was some ancient word for, maps or legends or something like that. Okay. So, let's look at this. What's that? It's French?
It sounds French.
It kind of does, huh? All right, so let's say that this is Idaho Falls, right there, that dot. Tell me the coordinates of Idaho Falls on this map. I hear 2B and I hear
B2.
B2. Okay, which one is it? Is it 2B or is it B2?
B2.
Okay, so we came back to it and you're all in consensus that B2 is definitely Idaho Falls. Why did you change this? Why is it B2? Okay, so your horizontal axis is always your first coordinate. Okay, and this is in every mapping system that exists in the world. I don't care if it's a paper map about streets or highways, or if you're talking about latitude and longitude and anything like that, or math. Every mapping system, you have 2 coordinates to get to one point, and your first coordinate is always your horizontal coordinate. Okay. On this map, where would you put Rexburg in relation to Idaho Falls? Where would you put Rexburg? Give me what
Probably
coordinates.
E5.
E5. Okay. E5. I might move it over a little bit this way. That's pretty. I might get a little bit closer. Maybe let's go D5 or D6 in that range. That's cool. Okay, I like that. And notice that this is not an exact science. I mean, you bring this over. It's kind of closer to 6, right? But some of the stuff like this is at D5. Okay. And if you remember, and this is what I remember being on a mission, is people would give us, their addresses, right? And oh yeah, come and visit us. We look them up on the maps, and their bogus addresses, right? And then when you found an address that was real, you're all excited, okay? But you'd have to look at this glossary of all these names in the town of streets, Davis Street. You look up Davis Street, and then it exists, And then, it would say like Davis Street's at, D5, and then you'd look at there'd be all these little roads and stuff, and you'd be searching around, and then you find Davis Street, like, oh cool, and you go visit it, and it ended up being like a dairy or something. Like, I don't know, that's man. They sent us to the dairy. We used to buy milk. So, make lemonade. All right, where's Jackson Hole on this map? Where do you think Jackson Hole is?
F.
F? Okay. F what?
Pretty sure it's gonna be F, like 4, like.
Yeah, I like it. Yeah, it is. It's about
Like
right here. It's really interesting. Rexburg and Jackson Hole, Wyoming, and Idaho Falls, they kind of triangulate. They're actually almost equidistant from each other as the crow flies. It is interesting. Jackson is a little south of Rexburg, north of Idaho Falls, but they're kind of triangulated. All right. So we understand mapping systems. You don't need to write any of this in your notes today, but we are going to be talking about these same exact concepts translated from the real world into the math world. I want you to do something right now for unique. Okay, we are going to be talking about the topic known as lines in chapter 3. Okay, lines. And yes.
Are we gonna worry about X for some of these lines?
Oh yeah. Oh yeah.
All right, cool.
There's going to be variables in these
like
lines.
variables
Yeah.
and consecutive integers and all that stuff, right?
I thought you were going to go city on me and ask me if we're going to snort some lines, but
No, of course not.
No, of course not.
Yeah.
Of course
You got a
not.
credit card? Dice them up. I got a straw.
We have to do a razor.
All right, good man to joke with me. Okay, I had one girl in class that was all about this, and she started, telling us, that her credit card worked better than razor blade and all this kind of stuff. And I was like, dude, you're saying way too much information. One boy was sitting on the front, he's just like, yeah. All right.
Yeah.
So lines. So we're not talking about any other shapes. We're not talking about parabolas. We're not talking about rectangles. We're just talking about lines in this chapter. We're going to talk about 4 topics with these lines, okay? We're going to talk about the basics of lines. What does that mean? We're going to tell you. We're going to talk about how to graph lines. We're going to talk about how to find their slope. And we're going to talk about how to find their equations in this chapter, okay? And today we're going to jump around a little bit. So what I want you to do right now, before I do this, though, we're going to make a visual chart at the end of this chapter, and it's going to only have 4 boxes. And this one's going to go here, and this one's going to go here, and this one's going to go here, and this one's going to go here. And so what I want you to do right now, okay? All right, Nikita, can I borrow your notebook? Your notebook. Yeah. Oh, hey, close. Come on.
Oh, sorry.
You're good. Oh, there's a love letter in here. Dear Julia. Who's Julia?
Your ex-wife?
Ah, yeah. I'll tell you what, that's why she's my ex. So listen, man, okay? So I want you to take a sheet of paper here, and at the top of this, I want you to write Chapter 3 lines, basics. And then I want you to turn the page, not to the back side, but to the next page, and I want you to write Chapter 3 lines, graphing, or graphs. And I want you to do the same thing for slope and the same thing for equation. So right now, you are going to label 4 sheets of paper, wherever you're at in your book. You're going to label 4 sheets of paper, each of these 4 topics. You got to trust me on this, okay? Because this is how we're going to teach you. This is how the test is going to be organized. And we're going to move around from topic to topic. So I'm going to be giving you some information. I'm going to say, okay, write this down in your notes on basics. And you go to your basics page. And I say, okay, now we're going to go to slope. And you jump to your slope page. And okay, now we're back to graphing. You got me? And then but we're not going to complete all of our knowledge about basics today. We're going to do some basics today and some graphing today. Then we'll go back to basics. Then we'll do some more graphing later. So we're going to bounce around from these 4 pages. The nice thing is when we're all done in just a matter of a few days, because we're only covering 4 topics, so this test is going to be end of next week. Yeah. When we're all done, these 4 pages, you can just transfer them into make this visual chart. Everything you need for your visual chart will be in these 4 pages. Examples, step-by-step processes, everything you need. Okay, so the first thing we're going to teach you is about the mapping system that exists in math. But before I do, there is a mapping system that exists in the military. Have you ever watched those military movies? You know, where, you know, the good guys or the guys you're, you know, following, the antagonist or protagonist or whatever the protagonist that you are following, they're under siege, right? They're under siege, and they're getting killed and losing some of their guys, and they're surrounded, and it's like, you know, they're in peril. What's that?
It's like the end of the world for them.
Yeah, and so they get on their communication radio system, whatever they've got, and they call in for backup. They call in for air support, and they say, "Bring the rain! Bring the rain!" What does "bring the rain" mean?
Bring in the airstrike.
Yeah, bring in the airstrikes, man. Bring in the artillery, man. Drop the bombs. You know, everything you got. And they call in their coordinates. And those coordinates are measured in what's called degrees, minutes, and seconds. And it's not time. It's actually a location. But it's so specific that it is 6 digits, okay? It is literally 000000, okay? And it's a degree, minute, second kind of a situation, all right? And those measurements, do you know what they're called? Do you know what the x-axis and the y-axis of those measurements are?
The longitude and latitude.
Way to go, my brother,
Yeah.
okay? But what's the first one? What's the horizontal one?
Longitude.
It's latitude, okay? And this is longitude, okay? All right? And so the equator is what?
Latitude.
Latitude, right? And what's its measurement? It's 0.
Zero.
It's 0, okay? Very good. And so you call that in, and they can stick a bomb through your freaking front door. Okay, that's how precise they can get that, all right? Now, who speaks Spanish in here? Who are my Spanish speakers?
Poquito.
Poquito? All right. Is So the Mexicans have a statement they use a lot called más o menos. Okay, it means more or less. Okay, and is this if you're calling in an airstrike to support you? Is this a kind of generalized, more or less, hit this area, or do you need to be very specific?
Very specific.
Why do you need to be very specific?
No bomber people.
Yeah, you're gonna die yourself if you don't call it in exact. All right, they got to know exactly where you are, okay, and then because they gotta avoid you, okay, they don't want to kill you. All right, okay, that's cool. All right, bring the rain, man. It's funny things that people they don't know in life, and I think the more you learn about language, the kind of interesting it is. But my sons play soccer for Sugar, and they brought home the first ever state championship this past fall, this year. Okay, it was 2021, but anyways, and it was really exciting, and they've had some really good soccer teams over the years, but the state is really good in soccer overall, and so, but they brought home the state championship this year, and they had, every time they get in their huddle, right before the game started, they would all, get together and say, "Bring the rain!" Everybody just yells this out, And one day I asked my sons, I'm like, "Do you know what that means?" And they're like, "I don't know. It's like rain down on them." Okay. They didn't know what it meant. So it's just kind of funny sometimes these little phrases that we use in life, we don't really know what they mean. Okay. All right.
Like fetchers.
Like fetchers. That's right, man. Fetch you, fetch me, fetch everybody.
Oddball question.
You have a question? I'm ready for it.
Are we gonna deal with like the crazy hot matrix?
The crazy hot matrix.
I'll show you a video like it's someone dealing with like.
Oh, okay. The three-dimensional or four-dimensional world of the Matrix? Probably not.
No,
Probably
I'll show you the video if you have time.
Yeah, sounds good, man.
For the end of the class period.
Sounds good. So, what's this axis called right here? What's this axis called right here? That's the x-axis, all right? And it is the horizontal axis. If you don't know the words horizontal and vertical, it's time to memorize. What's this one called?
Vertical axis.
The vertical or what?
Y.
It's the y-axis, right? And if you don't memorize these, I'll kick your axis. There you go. All right. What's this point right here?
0.
0, 0. Very good. It has a name. Origin. And the reason it's called the origin is because all of our movement on this graphing system, it starts right here. It originates at 0, 0. We start here, and everything we do starts from right here, with one exception. We'll talk about that exception in a few days, but not today. This mapping system in math, it's called the Cartesian coordinate plane. You don't have to memorize that. You don't even have to write it down. We're not going to ask you to know that, but it is called the Cartesian coordinate plane. Tonight in your homework, they're going to put something like this right here and say this is A, and maybe they'll put something right here and call this B, and then they might put something right here and call it C, and they'll ask you, identify the coordinates of points A, B, and C. So everybody help me out here, okay? What's the coordinates of point A? Help me. It's what? Say it loud. 3, comma, 2 or 3? 2. Yep, 3, 2. Okay, so we go over 1, 2, 3, and up 1, 2. All right. All right. How about B? What's B?
0.
3, 0.
Oh, 0, comma, 3. Okay, I heard 3, 0 as well. Okay. Our first movement would always be to the right and left. So 1, 2, 3, 0 would be this, but this is 0 this way and 3 that way, so it's 0, 3. Okay, what's C? What's C? Okay, so it's how about negative what?
1.
Negative 1.
Negative 3.
Negative 3. Okay, so again, we got our left and right movement, so it's negative 1 and then down 1, 2, 3. Okay, we cool? Okay? So could you get these mixed up? Yes, you can. So, this is a chapter that's not difficult, but there's a lot of opposites going on. You can get them mixed up. Okay, every one of these points here is called an ordered pair, right? Ordered pair. An ordered pair equals a point, P-O-I-N-T, all right? And every ordered pair has 2 coordinates, right? Because, again, if we're on a mapping system and I tell you to bring the fetching rain, okay, and I tell you, and I'm, just going to bring it to my town, so we're going to bring it to my street system here, okay? Like, bring the rain, okay? And I tell you, I'm at B, Thanks a lot. I could be anywhere along B forever and ever and ever and ever, right? I gotta give you B2. Now bring the ring, all right?
Bomb you.
Bomb my fetching neighbor whose dog craps in my lawn or something. I don't know, you know.
I mean,
I don't have any neighbors. I live out in the middle of a 16-acre farm. I'm a half a mile away from my closest neighbor.
that's cool.
2 miles away from the next one, so yeah. I don't care who craps in my lawn. I had a moose up there crapping the other day. So, all right. So every ordered pair is a point. It's called an ordered pair because the coordinates come in alphabetical order, and we always have the horizontal coordinate. So this is called your horizontal or x coordinate. All right, and it always is the first coordinate. Your second is your vertical, okay, or your y coordinate. All right. So you can call this the second coordinate, the vertical coordinate, or the y coordinate. The first coordinate, the horizontal coordinate, the x coordinate. Okay, we cool? All right. Next thing. Then they're going to give you like points D, E, and F, and they're going to tell you to plot them. What does plot mean? Place, graph. Yeah, it really means just to graph them. Place them on the graph. And so let's go ahead and let's graph negative 2. Okay. How about negative 2, 2? How about 3, negative 1? And how about 2, 0? Okay, so let's do these. So help me out here. Negative 2, 2. You guys tell me what to do. I'm here at the origin. Where do I go first? Left 2 and
Down.
Up 2.
up 2. So I'm right there. What coordinate was this?
D.
D. In case you're going to write that tonight on your mapping system here. Okay. Go ahead. The next one. What do I do?
Over to the right 3.
1, 2, 3.
Down 1.
Down 1. Okay. And this is letter E. Okay. Let's drop the F bomb. Where's it going? Where's it going?
Over to the right 2.
It's going to the right. 1, 2, and then
And
0.
stay
So that's it right there. So that's the F. Okay. All right. So now the next thing that they're going to ask you to do. We're almost halfway through your homework tonight. Okay. This is the easy stuff. Really easy stuff. None of it's hard. Okay. Each of these quadrants is given a Roman numeral. Obviously, there's 4 quadrants. Okay, but they don't numerically list them as 1, 2, 3, and 4. Probably because there's a lot of numbers going on already. So they just call this, Roman numeral 1, 2, 3, and 4. But notice how it goes counterclockwise, right? Always starting in the upper right-hand side. Every coordinate here will be a positive and a positive. Your x will be positive, your y will be positive. Help me right now. In this one, your x will be what? Negative, and your y will be positive. Over here, your x will be
Negative.
and your y will be
Negative.
so we got negative and negative. Over here, your x will be
Positive.
positive, but your y will be
Negative.
negative. Very good, right? And you don't have to memorize all that negative, positive, all that crap. You figure it out, okay? But right now, they're going to say, okay, so what quadrant are each of these points in? So what quadrant was point A in?
1.
Obviously 1. Okay, how about B? B.
1, 2.
1 or 2? Okay, so it's not in a quadrant, it's on the y-axis, okay? Now, in the back of the book tonight, it's not even going to say the x or y, it's going to say on an axis. Like, it's too hard for you to identify it's x or y. These guys are going lightweight. Yes. Okay. All right, so this one right here, see?
3.
Yeah, you can see it's in 3, okay? And we won't do the rest of them, you're fine. You got this? Okay, let's think about this for just a second. This goes in your notes on basics. Okay, so that very first page you put together. And again, this isn't everything about basics, but it's a good chunk of your basics. So go ahead and write all of this down about basics, the ordered pair, all this crap, blah, blah, blah. We cool? We cool. Okay, go for it.
Cool as ice.
Nice. Okay. You do that. And I do this. Did you take roll today?
Mhm.
Yeah? You rolling?
Yep.
George! How you doing, man?
Good, how are you?
I'm so good. Don't tell me your last name. It's George.
Of the jungle.
No, Jack.
Sorry about that, George.
Is somebody? Oh. Thatch. Ashcraft.
No.
Pretty
No?
close though.
What is it?
Ashworth.
Ashworth. Oh, fetch. I have some Ashcrafts in my ward. Okay, George Ashworth. Okay, cool. Adrian Asuncion. Yes?
Yeah.
Yeah. Date my ex-wife. Kyle Bad Boy Baird. Yeah. How you doing, bro? What's your middle name?
Scott.
Got?
Scott.
Oh, you said Got. I was like, wow, man. You can mess with that name a lot, you know? Kyle got.
Bear.
Yeah, man. All right. Scott and Rachel Bedford, not to be mistaken with Rachel Ford. Very good, very good. Let's see here. Caitlin. Yeah, Caitlin. You know, so funny. You don't look the same in your picture.
I know.
You know, you look better in real life.
Oh, thank you.
Much better. Cool shoes, by the way.
Thanks.
Matt? What's up, my man? Dude, say something.
Hi.
Hi. You're a man of few words, aren't you?
Sometimes.
Sometimes. He's got that deep voice. Do I say your last name Brixie?
Absolutely.
That's cool. That's a cool last name.
Thank you.
Where's that from? England?
I think it derives from like Irish.
Oh, cool. Cool. Somewhere in the British Isles there.
Yeah.
That's cool. Let's see here. I'm missing. Is Jack Carline? He's not here today, is he? Hayden goes to the 9 a.m. class. Where's Anna Lee? Anna Lee's not here. Oh no. How do you say your last name?
Flickiger.
Yeah, that's an F word. That's a dangerous one. Like saying your last name could get me in trouble. Okay? It's kind of a cool name. I think your husband should take that name. You know what I'm saying? Do you agree?
Sure.
Sure? Yeah.
That's what I told my husband.
Yeah? That's cool. That's awesome. You look really different too than your picture. That's crazy. Okay, you guys got all this down? Or you still need a minute? Who needs a minute? Say will.
Well,
All right, keep
is
moving.
this like the quiz, like, or is this just like notes?
Today, your participation in class is your quiz.
Oh,
Yeah.
okay.
Yep. Maddie Hyde.
I just like looking at the roll sheet and just.
No, I'm looking at pictures and seeing if I know your names.
Oh, okay.
And then if I'm forgetting, I'm having to look at you and be like,
Easy. Just think of Texas.
yeah, Austin, man, come on, you bro. Drinking from the vines.
Yeah. I've actually made my own wine.
Have you?
Yeah.
And have you drank it?
Yeah, I drank it, but like you know how like with
Austin, man.
Mhm.
This is against the word of wisdom.
I mean, like, I was young, and I just wanted to try the alcoholic process for myself.
Wow.
So it was like a way to sneak my way out of that whole, like, under 21 thing. Yeah, so, like, I was like, easy way to make alcohol. Just
This is fascinating. Austin would be fun to hang out with at a party. You know what I'm saying? I mean, just be like, hey,
we should
I've
have
made
a
my,
match
I've
party.
made my own booze.
Yeah. But the dangers of like making my own booze, like, was like, I could have got like alcohol intoxication. So like,
Sure.
I just like took a couple swigs of it and like, yeah.
And then sold it.
I didn't sell it. I just,
You weren't moonshining.
yeah, of course not.
Clara? Yeah? What's up?
Nothing much.
Jensen, right? Jensen. Alright, and Ethan.
Yep.
What's up, my man? That's good. Your last name is kind of interesting. Julander?
It goes Julander, or you can skip the change and say Ulander.
Oh, what do you do?
What?
What do you say?
Normally Julander. 'Cause
Okay.
That's how a lot of people in America say it.
Yeah, wasn't there a
Where are
movie
you
about
from?
you? Oh, Zoolander. Zoolander. That's funny. That's funny. All right, guys, let's do our next thing here. Okay. Okay, I want you to flip over to your page of about graphs. A graph. Okay. We're gonna talk about graphing real quick. All right, I got a question for you. I want you to answer this. I want you to think about it before you answer it, okay? How many points do you need to graph a line? How many points do you need to graph a line? Think. Answer.
2.
All right. I want you to repeat the following after me. 1 is a dot.
One is a dot.
Do it again. 1 is a dot.
1 is a
One
dot.
is a dot.
2 is a line.
2 is a line.
3 or more.
3 or more.
Wasting my time.
Wasting my time.
All right, let's put it all together. 1 is a dot.
1 is a dot.
2 is a line.
2 is a line.
3 or more.
3 or more.
Wasting my time.
Waste my time.
All right. So, if you only have 1 point, you don't have a line. You got a dot. Okay, you understand that? If I got 1 point here, like D, and I'm telling you I can go any direction from there. You know what I'm saying? But if I tell you I got D and F, it's going through those two, right? Everything else along that line is a waste of my time once I connect the 2 dots. So how many points do you need to graph a line?
2.
Exactly. And so you're going to learn how to graph, but at the core of it, you got to understand the goal is to find 2 points. So, graphing. Okay? Lines. We need 2 points. Always. Okay? There are 3 methods to graphing lines. 3 methods to graphing lines. And the first one is called the plug and chug method. Right? The second one is called the intercept. You can write while I'm writing. And the third is called the y equals mx plus b method. Now please, please, please pay attention. These are not the 3 steps to how we graph lines. These are 3 different methods of which we have to learn steps for each one. Why would we learn 3 methods of graphing? I mean, I just kind of talked to you about the efficiency of graphing a line. We're saying, look, 1 is a dot, 2 is a line. Any more than that, we're wasting our time. Are we not wasting our time if we learn 3 methods to accomplish 1 task? Maybe, but not in this instance. Each of these methods will teach us something unique that we must know. Today, we're going to learn the plug and chug method, and only the plug and chug method. So we're going to go ahead and write the steps down to that right now. So go ahead and keep writing while I'm writing. Plug and chug method.
Do you want this on graphing or?
Yeah, this is all in your graphing notes. Graphing, lines, okay? Middle board was basics. This is graphing. Plug and chug method. Step number 1, we're going to pick our nose. No, pick a value for x. Number 2, we're going to plug it in the equation, hence the word plug in plug and chug. Step number 3, we're going to solve for y. So we're going to plug in a value of x and chug out a value of y. That's why it's called plug and chug. Plug in x, chug out y. We're going to repeat this process to get our second point. And then we're going to do what I like to call plot the dots and connect. Okay, going to connect them. I got to erase the middle board. You guys cool? You good with this?
Yes.
All right, so you can keep writing for a second. We're going to graph our first line together in this class. We're going to graph this equation right here. So I want us to graph 2x plus 3y equals -6. 2x plus 3y equals -6. We cool? Well,
Are you asking us how we should solve it, or do we
Step
understand
number 1.
what you said?
let's go ahead. Let's look at step number 1. Look at step number 1 right here.
Solve for x.
Okay, we're going to pick a value of x. So let's let x equal something. What do you want x to equal?
0.
What do you guys say? You guys, not you. You guys. What do you guys say?
0.
Okay, here's 0. Here 1. Okay, let x equal 0. This is the best first option. Okay. Alex, you can't keep giving them the answers. You naughty little TA. Okay. All right. They always say 1. Okay, and then I change it to 0, and they're like, oh, you always do this to me. Okay. The best one to pick is 0. So somebody could say, well, why don't you just say let x equal 0? Because we have to repeat this process. You'll see here in a minute. Okay, step number 2, we're going to plug it into the equation. So we take 2x plus 3y equals negative 6, okay? These are your steps. And we're going to plug 0 in for x, okay? So here's 0. We're going to put it right here. We got 0. And we got 2 times 0 plus 3y equals negative 6. It's gone. 3y equals negative 6. So step number 3, we solve for this. Do you see the beauty of picking 0? Yes or no?
Yes.
Yeah, it cancels out. So rapid. Divide by 3, divide by 3. Y equals negative 2. Now I'm going to ask you a question, and I want you to think before you answer it. Right now, how many points do you have? Wait. Answer it. 1. Okay, why'd you say 2? Rachel, why'd you say 2?
Well, because I was thinking of like step number 2, but it's at the end of 3, you only have 1.
Right now we have 1 point, right? We have an x coordinate and we have a y coordinate. Sometimes people think that the x coordinate is 1 point and the y coordinate is the other point. Every point has to have an x and a y. We talked about that, right? Every point has to have both coordinates. So our x and our y coordinate are 0, negative 2. That's our first point, so point 1. Understood? So how many points do we need to graph a line?
2.
How many do we have right now?
1.
So we need another one. That's why step number 4 says repeat the process. So we're going to let x equal, we got to pick another number. What do you want to pick this time?
1.
Okay? If we pick 0, we'll get the exact same point, and we'll only have 1 point, right? If we plug 0 and we solve it, we're going to get negative 2 again, right? You know what I'm saying? Because you plug 0 back into this, we're going to get negative 2 all over again, so we'll only have 1 point. We've got to have a separate point, so we can't pick 0 again. So what number do you guys want to pick?
Negative 1.
Yeah, I hear 1, I hear negative 1, okay? Let me share something with you. Look up here. So we definitely want to keep our math as easy as possible. By the way, I get students all the time when they get this chapter, like, hey, Brother Rich, do we have to buy graph paper? Did I? Nope, you just draw it. Okay? A lot of drug, references going on in this chapter. Lines, hash marks, okay? You got me? Okay, so just hash it up. And, yeah, who knows? Maybe the devil's cabbage will be your friend. Listen, you guys...
It's not really.
No. So you guys don't have to buy graph paper. Okay, you can just draw it on your paper. No big deal. We're not going to dock you points. Alex doesn't care. He just wants it to be legible. Look up here, please. Our first point is 0, negative 2. Understand? Right there. Right there. You got that? If you pick 1, I want you to get this. If you pick 1, wherever 1 is, you're only going to have that much distance between the first point and the second point. So when you go to connect those, you're only going to be connecting them here. And you could get off a little bit, and you got to understand that if you go a little bit more distance, you're going to be more accurate. And so I would pick a number a little further away than just 1, 2,
Negative
3,
5.
4, something like that. Okay? But the bigger the number, the more math you have to do. Okay? Let's go ahead and pick a number.
Negative 5.
You want negative 5. That's interesting. I've never had anybody pick a negative number before. I love this. Okay? And so we get 2 times negative 5, okay, plus 3y equals negative 6. Now look at this. We have negative 5 right here. Okay, good. And so, equals negative 6. Yep. And we're going to solve this. Negative 10 plus 3y equals negative 6. We're going to add 10 and add 10. We're going to get 3y. This cancels equals positive 4. Divide by 3, and we get y equals 4/3. And so our second point, point 2, is going to be negative 5, comma, 4/3. However, if you're like me, 4/3 means nothing. When I'm graphing, I got to have like 1 1/3, or I could divide these on a calculator and have 1.333333. And so I'm like, okay, this is negative 5, comma, 1.333 forever and ever and ever. That I can, approximate and graph on here. So my last step number 5, right here, is plot the dots and connect them. So my first dot is 0, hey, 0, and then negative 2?
No.
Or 0 and then negative 2? Which one?
0, negative 2.
Yep, this one, 0, negative 2, right there. Okay, and then I have negative 1, 2, 3, 4, 5, and I'm going to go up 1 1/3, which would put me about right there. Okay, y'all cool with that?
Yep.
And then we connect them. And there's my line, and I'm done. Okay, graphic, hard or easy? Pretty easy. Who's done this before? Say woo.
Woo.
Of course you have. Okay, part of your upbringing when you went to school. Okay, tonight in your homework, please pay attention. I need you to get this. Okay? I'm not going to have you pull up your homework. I'm going to show you myself. Okay? In the beginning, so watch this. In the beginning, the first 2 pages, they're going to do a whole bunch of this crap that we just did where it's like, hey, what's the coordinates of point A, and what quadrant is point A, B, and C in, and all that kind of stuff. Super easy stuff. It's going to take you to about 1/3, maybe 40% of the way through the homework. And then they're going to have you graph lines. Please look at these charts. Okay? And look at what they do. They give you the values of X. They don't let you pick. They take away your agency. This is Satan's plan. Okay? How many points right there, Nikita? How many points do they give you?
6.
6. I only got one thing to say about that. Waste of your time. Okay? Waste of your time, right? 1 is a dot. 2 is all you need. 2 is a line. 6 of these, waste of your fetching time. So we're not going to follow the book's directions. And if you look at this published assignment, it says, and whatever we start with, number, 35 to whatever number of this one we do. So it tells you numbers 35 to 47 or 51 or whatever. It tells you don't follow the book directions. Use the method we did in class, plug and chug, okay? Now, how many people in here know a different method to graphing lines than this one? Raise your hand if you know a different method to graphing lines, okay? So a few of you know a different method. What method do you know? Do you know what it's called?
No.
What? Y equals mx plus b. Yeah, that's a really good method, okay? Listen, don't use that tonight. We are going to learn that when we go there. You're like, ooh, I'm good at this. I know this, But right now, I want you to use plug and chug method tonight because each method is going to teach us something we must know. Okay, you guys cool? So tonight, you use plug and chug method. Don't use these charts. Come up with your own values. Don't do 6 dots. What a waste of your time. Just do 2. Connect the dots. You're good to go. Cool? Okay, I want you to finish writing all this down, and then I want you guys to graph 3x plus 4y. Okay, you're going to graph 3x plus 4y equals negative 12. Go! Do your thing. I'm going to do my thing for a second. Okay?
Overturn.
Okay, he got beat up at school. He came home. You can understand, my dad's dead. Okay, he was born in 1927. You can understand, this is probably the early to mid 1930s, right? It's during the Depression. So he comes home from school one day, and he's been beat up at school, and he's crying. And he comes in the house, and his old man sees him crying, and he says, and my dad's name was Morris. That's kind of funny. He says, Morris, what are you crying about? And he's like, Johnny Uzito beat me up at school, And he says, get out of this house. Don't you come home till you kick the bleep out of Johnny Uzito. And he looks at him kind of like, what? He's like, you heard me. Get out. Don't you come home until you beat up Johnny Uzito. Well, Johnny Uzito lives 5 miles away. And this is the 1930s, okay? So Morris leaves home, tears run down his face, and goes and finds Johnny Uzito's home. And everybody in the community knew each other.
Yeah.
So he walks 5 miles to Johnny Uzito's place, and he raps on the door. And nice little Mrs. Uzito comes to the door. She's like, oh, Morris, what's wrong? She can see Morris has been crying. He's like, I gotta kick Johnny's bleep. He says ASS. I gotta kick Johnny's bleep. I can't go home. And Johnny Uzito comes out, and let me tell you something. My dad kicked the living crap out of him. Yeah, and that's how I was brought up.
Wait, what?
When your life depends on it, when your food depends on it, when your bed depends on it, it's amazing what you can accomplish. So we were brought up tough. We were gritty, tough men.
Wait, so you're a part of...
You missed half the story. You were going potty or something.
I was. No.
His dad, when his dad was young, his dad went over to this boy's house because his father told him he couldn't come home unless he beat up this one kid
Oh.
that beat him up.
Is your dad a boomer or Gen X?
I don't even know which those apply to. He was born in 1927. He was during the Depression and all that kind of stuff.
So more like pre-boomer
Yeah, probably.
Yeah.
I'll search it up.
Okay, did you guys get this? You done?
Yeah.
Okay, all right, let's graph this real quick. What did you pick for your first value of x?
0.
Oh, I love you guys. Good job, you're learning. 3 times 0 plus 4y equals negative 12. This cancels out. 4y equals negative 12. You divided by 4, you divided by 4. You got y equals negative 3. Your first point was?
0, negative.
Very good. But you need a second point, and so what'd you pick on the next one? By the way, can I tell you another little secret? Okay, you see how that creates a fraction? It's often going to create fractions, but if you think, you can pick a number that avoids fractions. Okay? Go ahead, what'd you pick?
4.
Let x equal what?
Negative 4.
Negative 4. Okay, so 3 times negative 4 plus 4y equals negative 12. I'm impressed. Did you pick negative 4? All right, you're kind of using the intercept method. It's okay. Negative 12 plus 4y equals negative 12. So we add 12 to each side, and these cancel, and we get 4y equals 0. Divide by 4, and y equals 0. Doesn't matter what you do, but you got negative 4 comma 0. And so we come over here, and we got 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And it's okay. You picked values of x and shoved out values of y, and you used your intuition to help things cancel out here. 0 this way, negative 3. This is the big problem here. Because we get used to our left-right movement being first, sometimes people go 0 and then negative 3. Don't do that. Okay, and then negative 1, 2, 3, 4, and 0, and then we connect the two. Did your line look like that? Say woo if it did.
Woo.
Okay, that's pretty much everything you need to know with one small exception. I got to erase these boards, so finish taking notes on this. This is all under graphing, and then we're going to go back to basics. And I'm going to teach you one more concept about basics, okay? I will tell you, growing up rough or challenging like that, it has its benefits and it has its curses. You know? Its benefit is you're gritty, you're tough. That same old man that kicked Morris out of the house and made him go fight for his bed and his food that night, he built the first highways in the state of Nevada. And he ran a road grader. And one day he was driving a road grader, and he leaned over to look at something out the back of that road grader, and a branch from a tree, as he was driving it forward, caught his shirt collar, pulled him off the road grader, and these are the ones with tires like this big, and the road grader ran him over. He rushed him to the ER, thought he would die. He survived. They told him, you will never walk again. You're done, man. The rest of your life. 6 months later, he was out working on the road crew. He walked the rest of his life. I mean, he was he was like, that's the whole point. He said, screw you. He wasn't going to take that. He figured a way out. And he worked the rest of his life. And he was a tough man. I didn't even remember him having a limp as a grandson. But, so you're gritty, you're tough, you can endure a lot of stuff, but you're a fighter. You get yourself in trouble sometimes because, it's like, now and then somebody says something to me and I'm just like, did you fight your pop? I'm like, what'd you say to me, man? Like, I was stopped, you don't put up with crap, And my boys, it's funny, they're like, hey, Dad, teach us how to fight. And I said, you want to know what my dad taught me? First lesson? He's like, you don't throw one punch. He says, you just keep punching until you can't breathe and people are pulling you off them. He's like, don't you freaking stop punching. You punch and punch and punch and punch and punch, and you're a Tasmanian freaking devil. He said, you will never be a big man. You're a Llewellyn. You will be short and feisty. So size is not on your side. So you just got to keep punching until, somebody pulls you off and says, dude, you got to stop, man. Look at that. Oh my gosh, we're taking him to the ER. Oh, good. I won. Ding, ding, ding.
I've never gotten in a fight before. by the
That's
way.
wonderful. Don't get in a fight. You don't need to.
Of course, yeah. There's no need.
No need at all. Absolutely.
Do the BFC.
Amen, man. Be a pacifist. Be a peacemaker.
But you said there's no reason to fight.
Okay.
Well, I would go with this. I would go with the talking it out route. And then, like, if the situation escalates and calls for it, that's like my last resort. I use it as a last resort means. Like, does that sound good?
Sounds real good.
Yeah, let's talk it out. Let's see if we can get heated a little bit, but like if we get boiled over, then yeah.
Okay, everybody, our last 5 minutes of class. Ready for this? And we had fun talking about crazy crap today. You're bat crap crazy. A little bit. Look up here. 2x plus 3y equals negative 6. What's this? What is this?
A line.
Is it that?
Technically.
Math is the manipulation of numbers to look
The same.
different,
But
but remain
The
the.
same.
Is this the same as this?
Yes.
You fetch and betcha. They are exactly the same. But this is an equation, and that is its line. Look up here. Is, ready for this? Is negative, I'm sorry, let's do this. Let's do, is 2, negative 2, a solution to the equation 2x plus 3y equals negative 6, okay? So if I wanted to know if that was a solution to that equation, what do? What do? Plug them in. I love it. Very good. Very intuitive. Okay? And so that's an x and that's a y. So where there's an x, I'll put in a 2. Where there's a y, I'll put in a negative 2. And I end up with 2 times 2, okay, plus, negative 2 times 3, or 3 times negative 2 equals negative 6. This ends up being 4 minus 6 equals negative 6. Does negative 2 equal negative 6? No, it does not. And so the answer to this is no. That is not a solution. Now, what if I said is, okay, ready for this, is negative 3, 0 a solution? To 2x plus 3y equals negative 6. So again, plug it in. I like this. So we say this is x, we say this is y, and we say, yep, that's negative 3, and that is 0. And we will multiply, 2 times negative 3 plus 3 times 0 equals negative 6. This cancels. We get negative 6 equals negative 6. Yes, indeed, that is true. Now watch this. This is fascinating. Look up here. Graph 2, negative 2. 1, 2, negative 1, 2. Is that point on that line? Negative 3, 0. Negative 3, 0. Is that point on that line?
Yes.
I want to teach you this one last concept. Again, all this goes in basics. Make sure you write that down in basics. I'm going to teach you this last little thing in basics, and we're going to get out of here, okay? In the math world, we call it an equation. An example would be 2x plus 3y equals negative 6. In the graphing world, we call that a line, and it looks like that, okay? In the math world, we call it a solution, okay? Sorry, this is the graphing world, okay? And so let's go with that, and let's understand that this equation is a line, okay? All right, a solution. And in the graphing world, we call it a point on the line, okay? And so an example would be, again, what do we come up with over there? Negative 3, comma 0, all right? And so we go, whoop, and there it is right there. There's negative 3, 0 right there. So, listen to this. Why do we graph? Because we are a visual people, and we love to see things to believe things. And we learn a lot from what we see. And so you say, well, look at this. Graphing is not precise. Math is precise. We get these exact numbers, like these little things with fractions and things we showed. So we have these exact numbers like negative 3, 0. But graphing, it's a more or less thing, but it gives us a visual. Do you guys understand that this line right here is what we call the 0 line? Do you understand that value is 0? It's like the equator. Everything above it is positive. Everything below it is
Negative.
So look at this. If this was the graph of one of our employees' performances over every month for the last year, what are we going to do with this employee?
Fire.
You're going to fire him, but at bare minimum, you're going to pull him in and have an evaluation and say, hey, look at your performance. But if we have a graph, we can show them, look, your performance has dropped month over month. Okay? So graphing gives us a visual on, the math world. You guys cool? One last question, we're going to head out of here. I want you to think before you answer. Think. How many dots, how many points are on this line? Think. Answer it. Say it loud. I heard somebody say
Infinite.
infinite. Look up here, man. This arrow goes forever and ever. It goes on forever. There's infinite points on that line.
Can you do that?
Look at, is that point on that line? So is infinity everything? It's not. Because there's infinite infinities. Wait, Are you infinite?
No.
Are you an infinite being?
Yeah.
If you say no, you're telling me that when you die, it's over. There's no more you. You don't exist. Are you an infinite being?
Yes.
Yeah, if you believe in this church, you better be. You are an infinite being. Are you everything?
No.
Well, to your mamas. But, listen to me. Same thing here. There are infinite lines all over this going all kinds of directions, right? Okay, just like we're infinite beings, but we are everything. There are infinite beings, there are infinite lines. Okay, what's the question?
So what stops the equation then from being an infinite amount?
What stops the equation from being an infinite amount?
like
Parameters.
looking at
Go ahead.
looking at the equation
Uh-huh.
and then understanding that like the equation equals that line, but
There are
is that-
infinite solutions to this equation.
Okay.
Be-
But how does
because
that
there are
like
infinite
stop?
points on the line.
Okay. I'm just wondering how that stops a student from like saying, oh, this is just like an infinite amount and getting like something right. Does that make sense? I don't know.
Well, here's the thing. Because everything is an ordered pair. There's order to the universe, there's order to this.
Yeah.
So, listen, we can't just say, we go back to this, we can't just say that x equals 2. X equals 2 when, y equals, and we can in here, so x equals 2 when y equals 3. Okay? Or negative 3. And so that's an ordered pair. Each of those ordered pairs then fills in a place on here. For another line, when 2 is 0, then that line maybe goes through here. Okay? When x is 2 and y is 0. So the ordered pairs kind of line it all out. You guys get out of here, deep thinking, but at the end of the day, your assignment's easy. Get that chapter 2 test done. I will see you tomorrow.